Hi guys, I'm Zibeon. I'm the laboratory supervisor here at the WestTrack SOS lab. We're set up here to do a whole bunch of different tests for you guys when you send your oils in. One of the main tests that we do here at the WestTrack SOS lab, and one that's hooked up to our next-gen system, is our particle counter. The way that this test works is that it sucks up your oil and it pumps it across the path of a laser. Any particles that are inside of your oil will flow across that laser and or interact with that laser, causing it to diffract or bend. What this system then does is it sees how much that laser bends or diffracts and how frequently it does that. And from there, it's able to give us both a count of how many particles are in your sample and at what size they are based on how much it interferes with that laser. Then at the end, we get a good snapshot of what particles are in your oil and at what size. The next test we do here at the SOS lab is a viscosity analysis. Essentially, the way this test works is we drop your oil in top of a tube that's sitting inside an oil bath at a set temperature. That oil then flows through that tube, getting heated up along the way until it starts flowing down the tube with the force of gravity. As it flows down that tube, it hits a whole bunch of lasers which record different times, which sees how fast it flows through that tube, and then at the end it's able to do some clever calculations in the background and produce that viscosity result for you. The next test that we do here at the WestTrack SOS lab is our ICP OES system. That stands for Inductively Coupled Plasma Optical Emission Spectra. The way that this test works is your oil sample is diluted with a special solution, which is then pumped into a spray chamber, turning it into a really fine mist. That mist is then sprayed across a really hot electronically generated plasma flame, burning at over 5,000 degrees Celsius. That's hotter than the surface of the sun. When it hits that flame, all of that energy from that flame breaks down your oil sample into its basic atomic elements. The energy it then absorbs in those elements is released as characteristic, unique wavelengths of light that are specific to certain elements. Those wavelengths are then detected by a detector in our unit here, and based on the intensity of the light generated at those wavelengths, it can then calculate the concentration of those elements. We use this system mainly to pick up all the wear metal particles that end up in your oil, so we can detect any faulty components and make sure that your machinery is operating the way it should. Another one of the main tests that we do here at the WestTrack SOS lab is our PQI test, otherwise known as a particle quantity index. This test is measuring how much ferrous material is inside of your oil. This ferrous material could be anything from iron shavings and particles from some of your machinery's components, or it can be high iron content dirt coming from iron ore operations getting into your sample. The way that this test works is it simply takes our sample bottle, places it on a platform, and rotates it around that platform. Underneath that platform are a variety of different magnetic fields, and as it travels through those magnetic fields, it's detecting how much it interferes and interacts with them. Based on how much it interacts with that magnetic field, it's able to calculate how much ferrous material is inside of your oil sample, and from there, we can make a judgment as to whether there's a high amount of iron particles or a high amount of iron-containing dirt in your sample. The results of this test give us an idea of when your coolant's due to be replaced. So either you're replacing it too early, wasting money, or if you're replacing it too late, you're risking your system overheating, breaking down, and costing you a lot more money down the road. Some of the other tests that we do here on coolant samples at the WestTrack SOS lab are pH conductivity and refractive index. pH conductivity is fairly simple. 2 probes go into your sample and they're able to give us a reading on both the pH and the conductivity of your coolant sample. Like the other tests that we do, this test can give us a snapshot on the health of your coolant sample, making sure that it's at the right specifications and at the right health to ensure that your machinery is running how it should and will continue running how it should. One of the other tests it does then after this is the refractive index meter over here. What this is testing for is the amount of glycol or ethylene glycol still in your coolant sample, otherwise known as antifreeze. The way it does that is it fills the cell inside of here with your coolant sample and then shines a specific wavelength of light through that cell. Based on the amount of light that's absorbed and allowed to travel through that cell, it can calculate the percentage by volume of ethylene glycol in your coolant sample. Again, giving us an idea of what the current state of your coolant sample is and whether it's in a good state to keep doing the job that it's supposed to do. This is our Carl Fisher apparatus, and this test allows us to calculate the percentage water content of your oil sample. The way that this test works is we take a small amount of your oil and put it into this little glass vial. That glass vial is then dropped into an oven where it heats up. Any water that's trapped in your oil is then turned into water vapor, which is then sucked up through this syringe and pumped into this reaction vessel over here. Inside that reaction vessel is a special solution that reacts with the water in what's called a redox reaction, which produces an electrical current. That electrical current then in turn produces a voltage, and this system's able to calculate that and pick up on it. Based on the amount of voltage that reaction creates, it's then able to back calculate how much water reacted with that solution and compare it to the starting weight of your oil to figure out the percentage water content of your oil. If there's too much water in your oil, in your machinery, it risks damaging your components, causing major breakdowns and massive amounts of downtime. So with this test, we're able to pick it up in its infant stages and make sure that your oil is always tip-top shape. If you're looking to get set up with SOS testing here at WesTrac, you can reach out to one of your friendly local branches, or you can visit us at westtrac.com.au and search SOS testing.